Hi, I'm Santos. Along with Dana, Ryan, and Chris, we are Team 17. This is Team 17's project proposal for FSE 100's Band in the Box. We were commissioned to design 4 unique instruments for the band Maroon and Gold 4 of Sparkyville. Our team had to ensure we produce at least 1 wind, 1 string, and 1 percussion instrument. The instruments are designed to play the song Ode to Joy with 4 ranges, high, mid-high, and low. The instruments were designed to fill a 2 by 2 by 2 foot box. As a team, we could not use more than 10 feet or 6 feet of string, with a budget of $15 per instrument. The design criteria are quality acoustics, portability, cost effectiveness, ease of design, and aesthetics. Quality acoustics was the more heavily weighted quality. My design was a wind instrument for the high range. We came up with 3 different ideas for this: a pan flute, a flute, and an organ. To find out which one would be easier to design, I had to first find the length of the tubes needed to cover 7 fundamental notes in the range of 261 to 587 Hz. The fundamental frequencies were calculated using A4 at 440 Hz as the reference note. The lengths were calculated for open and open closed tube design using MATLAB. As you can see on the graph, the open design would use less material, but the longest length exceeds the box size, leaving the pan flute as the most viable design. The weighted designs are represented here in the decision matrix for the wind instrument. With the design, I wanted to keep the tube radius small so I wouldn't have to use so much breadth. The materials I'll use are a half-inch PVC pipe glued together with hot glue that will be plugged at one end with hot glue. The longest length pipe will be about 12.9 inches and the shortest 5.7 inches. A total of 4.99 feet of pipe will be used, well below the 10 feet limit. At a cost of $1.27 per 23 inches of pipe, the total cost comes up to $2.59. Using my craft glue that I already have on hand, the cost stays there. And here is Dana with a mid-high range instrument.
Hello, I'm Dana, and I'm doing a small harp that's similar to a lap harp for the string instrument playing the mid to high part for Ode to Joy. On slide 7, I have included a technical drawing of the harp with my current estimated dimensions. Slide 8 shows my MATLAB figure of the string lengths as well as the string formula. My harp will have frequencies ranging from 277 through 523 Hz. Currently, I estimate to use approximately 3 feet of 24 gauge string. Which brings us to slide 9, where you will see my projected costs. I have already purchased the string and know the cost for it to be $2. I have nails and screws on hand, so I looked up the average cost of those and calculated per nail and screw based on how many I will use. As far as the wood I will use for the structure, I also have some on hand for the frame, and then we'll also need to purchase some. I have priced the one I will need to buy for the backing and added the costs in for it. Up next is Chris with the mid to low range instrument.
Thanks, guys. My name is Ryan Fletcher, and I've decided to do the percussion instrument for the low range for Ode to Joy for our group. Our group was originally considering between tube percussion instruments and bar percussion instruments. We were considering 3 different styles in the fact that we considered a hollow bar xylophone for one, a hollow bar chime, which would have vertical hanging bars, and then a solid bar xylophone, which would differ it from the original xylophone. The low range for Ode to Joy has 9 notes, and that would be G2, which is 97.99 Hertz, to A3, which is 220 Hertz. Considerations for tube radius and bar width were made based on the available materials in the local hardware store. And based on those materials, we input some dimensions into MATLAB to determine the required lengths for each bar type. So based on the graph shown, you can see that the hollow bar would require longer lengths for the dimensions that were easily available than the solid bar. Length was the primary factor there, and you can see the differences between the 2 xylophones primarily in determining that. So if you go to the next slide, you'll see the decision matrix that was used for all of the factors between the instruments, again leading to the solid bar being the primary contender for our consideration. So on the next slide there, you'll see the design for the actual instrument that we're considering building. The technical drawing there shows the dimensions. It looks like it's going to fit just within the 2 feet requirement. It originally intended to use a 1/2 inch width for the bars, but the length was just outside of range based on our calculations, so we had to dial it back a little bit to a 0.31 inch. And then we're going to build a support box with the bars put on top, and they'll be about 1 inch apart. The box and the bars will be held together using wood glue and nails. And then the wood glue is already on hand from a previous project, so the calculation for the actual total comes in just under the required $15 at $14.43 for my particular instrument. So based on that, you'll see on the next page the conclusion that we have drawn from our each set of instruments that we had considered, leading to our set being the best one for this actual design for the efficiency as well as the fitting in the 2x2x2 box, all using less than 10 feet of pipe and 6 feet of string or wire, and each instrument fell within the $15 range without sacrificing acoustics or the aesthetics. So these designs led to the most cost-effective and portable design, and the breakdown shown there in the decision matrix. So thank you very much.